this class, now I explain you standard form of a parabola and various forms of a parabola. Consider this Cartesian plane. So in which consider a fixed point, that is S, whose coordinates are a comma 0. As you know, this is origin. The distance from origin to S is small a. So now take the directrix over here. So you know the distance from origin to fixed point is equal to the distance from origin to the fixed line, that is small a units. Hence the equation of this fixed line, that is directrix, whose equation is x equal to minus a, or you can write it as x plus a is equal to 0. Now take the locus point anywhere on this curve. So now I am taking that locus point over here, whose coordinates are x1 comma y1. So it is locus point. You can take anywhere on this curve. Right, now I have taken a point over here, that is x1 comma y1. Now measure this distance S2P and measure the perpendicular distance from P to this fixed line, that is PM. As you know, for this parabola, SP by PM is called eccentricity, whose value is equal to 1. So here SP is how much? Root of the distance from here to here. So we get x minus a whole square plus y1 square, and measure the distance from P to this fixed line. How much is that? So we will get PM is equal to, so here x coefficient a into x1, here a value, coefficient of x is 1 into x1 plus, here there is no y term, so hence whose coefficient is 0 into y1, 0, not required to write, and here constant is a by root a square plus b square. So here a value is 1, b value is 0, hence in the denominator you will get 1. So here we have prepared SP and PM. So write that SP and PM value over here and go for simplification. Right, SP by PM is equal to 1, hence SP is equal to PM. Now SP value, square root of x1 minus a whole square plus y1 square, which is equal to PM mod of x1 plus a. Now square on both sides. If you take square on both sides, so here what do we get? Simplify this. x1 square plus a square minus 2ax1 plus y1 square, which is equal to x1 square plus a square plus 2ax1. So now x1 square can be cancelled, and a square also get cancelled. Now simplify this. On simplifying, we are going to get y1 square is equal to 4ax1. So here x1 y1 is a locus point. It is taken on the locus now. In the final step, replace this x1 y1 by x comma y. So here on replacing x1 y1 by x comma y, we get y square equal to 4ax. So this is known as standard form of parabola equation. See the standard form of the parabola. So whose equation is y square equal to 4ax, and this fixed point is known as focus, whose coordinates are a comma 0, and this is directrix. So whose equation is x plus a equal to 0. So here this x-axis is the axis of this parabola. What do we say x-axis for this parabola? Axis. So you know, on the x-axis y coordinate of every point is 0. Hence equation of y-axis is equation of this x-axis is y equal to 0. Y equal to 0 is the equation of axis of this y square equal to 4ax parabola. And you know the meaning of a chord. So chord will form by connecting any 2 points on the locus. So here many more chords you can draw for this parabola. Okay, see, whichever chords makes 90 degrees with this axis, which will be called double ordinates. Double ordinates. All these chords will make 90 degrees with axis of this parabola, hence which will be called double ordinate, because so in which this length is equal to this length. So this is here, this length, this is the y coordinate of this point, and this represents y coordinate of this point. So both will be equal, you know. So suppose here you may take this point coordinates as like x1 y1. So if this length is y1, this length will be also y1. So this is ordinate for this point and this is ordinate for this point. Both are equal, hence we are saying that, so this is called double ordinate. So similarly here many more double ordinates you can draw, but among all that, the double ordinate which passes through the focus is known as latus rectum. What is this? Latus rectum. So here actually it is a double ordinate, it is passing through the focus, hence it is called latus rectum, whose name is latus rectum. So let us consider whose end points coordinates as, see here, L dash. So you know, on the vertical line x coordinate of every point is same. Here on this latus rectum, one of the point x coordinate is A, hence L x coordinate also A, L dash x coordinate also A. So here in this parabola, in the place of x, if we write A here, then it will become y square is equal to 4a square. When you transfer square to the right side, we will get y equal to plus or minus 2a. So now here you take plus 2a and here it is minus 2a in the fourth quadrant. So these are the end points of or extremes of a latus rectum of this y square equal to 4ax parabola. So if we measure the distance from L to L dash, we will get 4a, because here it is 4a, here it is here it is 2a, here it is 2a, 2a plus 2a, 4a. So the length of the latus rectum is 4a units. Okay. So for the standard form of the parabola, here we have to remember focus coordinates. What are focus coordinates? A comma 0. And next you have to remember equation of directrix of this parabola. What is that? X plus a equal to 0. Next, length of the lattice rectum. How much is that? 4a. And end points of the lattice rectum. A comma 2a, a comma minus 2a. And next you have to remember equation of axis of the parabola. So for this parabola, so x-axis is the axis of the parabola whose equation is y equal to 0. Right. Here, if a is positive, then we get parabola which open this side along with the x-axis. Suppose if a may be negative, if a is negative, then you get a parabola which open this side along with the next negative x-axis. Observe that point. Right. Now let us go to the various forms of parabola. So suppose if axis of the parabola is y-axis, then we get the parabola like this, whose equation is x square is equal to 4ay, and here we get focus, fixed point, so whose coordinates will be 0 comma a, and whose directrix equation we get like this. Okay, you know the distance from origin to origin is the vertex of the parabola. So what is vertex? How this vertex will form? Point of intersection of the curve and axis is known as vertex. In the previous case also, for y square equal 4ax parabola also, origin is the vertex, because origin where the axis of the parabola and curve are intersecting, hence whose coordinates will be 0 comma 0. Here also vertex of this parabola 0 comma 0. So this distance is a, hence the distance from origin to directrix is here minus a. Hence the equation of this directrix, it is parallel to x-axis, no? Hence whose equation is y equal to minus a. If you bring this one left side, y plus a equal to 0. Okay, right. Now see, this is lattice rectum L dash, whose coordinates will be, so here minus 2a comma 0, minus 2a comma a we will get, and L dash, so here this is horizontal line. On the horizontal line, what do we know? So y coordinate of every point is same. Here one of the point y coordinate is a, hence this L y coordinates a, L dash y coordinates also a. So in the place of y, if you write a, so if you simplify, your respective x values will be plus or minus 2a, right? Minus 2a here, plus 2a here. So now measure the length from L to L dash. Here also we will get length of the lattice rectum 4a only we will get. Okay, right. Here what we have to remember? Standard form equation of this parabola. What is that? X square equal to 4ay. And then next we have to remember focus coordinates 0 comma a, and directrix equation y plus a equal to 0. And what is y axis? Axis of this parabola. So whose equation is, so you know on the y axis x coordinate of every point is equal to 0, hence x equal to 0 is the equation of this axis of this parabola. Okay, right. Now let us go to, so here also if a is positive, it open upwards. If a is negative, so it open downwards. Along with the negative y axis we will get. If a is negative, if a is positive, it open upwards. A is negative, it open downwards. Right. Next, every time this axis of parabola need not be x-axis or need not be y-axis. So sometimes axis of the parabola may be parallel to x-axis, may be parallel to y-axis. if the axis of the parabola is parallel to x-axis, then how we will get this parabola? Let us see that. Now, see. Okay, students, right. See, assume that this vertex of the parabola be h comma k. Now, this is axis. Now, how is this axis of this parabola? So, parallel to x-axis. And here, I have considered the vertex of this parabola be h comma k. You know the meaning of a vertex, point of intersection of axis and parabola is known as vertex. Here, vertex coordinates I have taken as h comma k. Now, tell me the fixed point coordinates, means focus. What are the coordinates of this focus? So, you know, the distance from here to vertex to the focus is small a, and from here to here it is h. So, this is h and this is a. Hence, x coordinate will be h plus a, and this is horizontal line. On the horizontal line, y coordinate of every point is same. So, here vertex y coordinate k, hence focus y coordinate also k. And where do we get directrix? Somewhere over here. So, shall I take over here? Now, this is a directrix for this parabola. Right, you know, the distance from this center to this, shall I take center as C? Center to this as small a. Hence, this length will be, students, a only. So, you know, the distance from here, this point to this vertex is h. From this h, subtract this a. From this h, if we subtract this a, so this length will be h minus a. So, this directrix of this parabola is moving h minus a distance from y axis. Hence, this directrix equation will be x is equal to h minus a. No confusion here. So, as you know, this length is equal to this length. This length we have taken a, hence this length will be a. From this entire length, h. So, from which I subtracted a. So, here, this is the distance between this directrix and y axis. Hence, the equation of this directrix is x is equal to h minus a. This directrix is moving how much far away from y axis? H minus a. Hence, whose equation will be x is equal to h minus a. Okay. Now, see the standard form of this parabola. If x-axis is axis of the parabola, whose standard form is y square is equal to 4ax. Now, how is this axis of this parabola? Parallel to x-axis. Hence, whose equation will be in the place of y, just you write y minus k whole square and 4a of x minus h whole square. 4a of x minus h, here square will not come. So, this is the equation of this parabola. Y minus k whole square is equal to 4a of x minus h. And next, this is what? Axis of the parabola. So, it is moving how much far away from x-axis? K units. Hence, y coordinate of every point on this axis is k only. So, hence the equation of this axis of this parabola is y equal to k. Okay. Now, let us see once again. See. What is the standard form of the parabola? If axis is parallel to x-axis, y minus k whole square is equal to 4a of x minus h, where h comma k is the vertex of this parabola. And focus coordinates, s is equal to h plus a comma k. and directrix equation x is equal to h minus a. Next, axis of this parabola y equal to k. So here now length of the lattice rectum will be 4a only. So if you simplify this, so you will get in this form, x is equal to some capital A y square capital B y plus capital C. If you simplify, we get this parabola equation in this form, x is equal to where A, capital B, capital C represents some real numbers. So on simplifying this, then this one will be transformed into this form, x is equal to ay square plus by plus c. So this is the equation of a parabola in which axis of the parabola is parallel to x-axis. Here also, if a is positive, so you get open parabola this side. If a is negative, this parabola will open this side. Observe that point. Next, suppose if the axis of the parabola is parallel to the y-axis, then we get like this, x dash, y dash, origin. Now take the parabola over here. So for this parabola, this will be the axis. Both are intersecting at this point. This is vertex. Assume this vertex coordinates as so h comma k. Now you know, if the axis of the parabola is y-axis, whose standard form is x square is equal to 4ay. And if the vertex is here, for this parabola, vertex is origin. If the vertex is shifted to origin to h comma k, then whose equation will be transformed as x minus h whole square, which is equal to 4a of y minus k. Now write the coordinates of this focus. So what do we get focus coordinates for this parabola? So it is a vertical line on which x coordinate of every point is same. Hence here, whose x coordinate is h and y coordinates from here to here distance a. So from here to here k. So k plus a you will get, k plus a. Now come to the directrix. Tell me the equation of this directrix. From here to here this length is k. So from here to here a. Now I want this length. This length will be how much? From this entire k, subtract this a, k minus a. So this directrix is moving how much far away from x-axis? K minus a units. Hence whose equation will be? So you know, y equal to k minus a. Hence the equation of this directrix is y equal to k minus a. Okay, right. Here for this parabola, equation is x minus h whole square, which is equal to 4a of y minus k. And if you simplify this, so we will get, so y is equal to capital X square, capital A x square, capital B x plus c. So if you simplify this, then it will be transformed into this form. Okay, so equation of this parabola is this, and whose focus coordinates are h comma k plus a, and directrix is y equal to k minus a, and vertex is h comma k, and no changes will come in the length of the lattice rectum. 4a only you will get. Okay, right. Now till now we have seen 4 forms of parabola. One is standard form, y square equal to 4ax, and the second one is x square equal to 4ay. Okay, next third one, y minus k whole square is equal to 4a of x minus h, and fourth one is this, x minus h whole square is equal to 4a of y minus k. In this 4, the axes were either x axis y axis or parallel, the axes were parallel to x axis or parallel to y axis. But every time equation of the parabola need not be either x axis y axis or parallel to x axis parallel to y axis. Suppose if the axis is given like this, and we have to determine equation of such parabola. See here, see, sometimes your parabola equation may be like this. Now, this is the axis of this parabola. Now, what is this axis? Neither parallel to x axis nor parallel to y axis. Neither x axis nor y axis, no. So, in this case, we have to determine this equation of the parabola means, so they will give you directrix equation. So, Lx plus my plus n equal to 0 will be given to you, and focus coordinate also will be given to you like alpha comma beta, and they will question you to find equation of this parabola. So in this case, what do they give us? Focus coordinates will be given to us alpha comma beta, and a directrix equation will be given to you, and they will ask you to find equation of this parabola. So for this, what you have to do? You have to apply that SP by PM equal to 1 concept. So consider a locus point on this parabola be x comma y or x1 comma y1, and measure SP length and PM length. Now apply this SP is equal to PM. Now what is SP? Square root of x1 minus alpha whole square y1 minus beta whole square, now which is equal to PM, perpendicular distance from this point to this line, mod of Lx1 plus My1 plus n by root L square plus m square, and go for simplification. On simplifying this, we will get equation of this parabola. Thank you.